Yes, now after writing the program or creating program from the software, which I'm using Autodesk Inventor 2027, and then I've programmed using our Ultimate Inventor 2027. Now here I've transferred the program to Sinutrain. What is this function that I had put? You see in the program I had put this one. So what is its meaning? This is just to tell the machine to go to a safe point, like TC homing the machine, where you can use G. You can put G00, G53, X00. Let's say you can put. Let me edit this one. Reset this. Then you can say G00, G53, X0, D0. So I can also do the G00, G53, Z0, D0. This is what this line is summarizing all this. So let me put semicolon behind so that it doesn't read. Then for this tool, I need to change this tool. This is OD facing. I can now select the tool here from my magazine to just update my OD naming of tools. So see how I've named my tools. This for facing. Then the next tool number 2 is for DNMG. That is OD55. This one, OD55. So we need to use OD55 tool number 2. Let's go to tool number 2 here. You see this. I want to go one by one. Tool number 7 is twist drill over diameter 12. So let's go to the next one here. We remove this one, then we select the tool. We go to twist drill 12 axial, and then we can put here even or we can now tell this one to go home. You see now this is what I was telling you. This is now telling the machine to go home, but I don't want to use this one. I can use L711. Simple to summarize this. This is an OEM code from the DMG Mori. It's not for all machines. This is from the DMG Mori machine. If you're using Siemens controller and machine, if it's manufactured from DMG Mori, and this is what we do. Okay, let's go to next. I will also tell you something when you are setting. I'll show you a simple program how it look like when you're setting. Then let's go to next. Is now this twist drill. I can use this one message blah blah. I can say this is drilling, and then I close this one syntax. I can go to last point here. Then I can say message. Inside I can say maybe close now the message display for that program. I can say also message. So this one, yes, and then close this. Go inside now, tell OD rough turning, and then I can change this one to either the M2 or M1. It's no problem. Then I can remove this one, the tool number 2. I'm using this tool OD. Let me show you the OD55. This OD55, this one, I'm using this tool. Okay, then let's go to the next. We'll see how we edit our program for threading. I'll show you how to do this one. This is now we stop this one message from showing. We use this message from showing, and then I can now say another message for grooving. This is now I can say OD grooving, and this grooving, my tool I'm using width of 3. So select the tool, put an OD groove of 3. This one left, okay, and this spindle should rotate which direction? M4. I say M4 equals to 4 because it's clockwise. But let me do a simple setup. Let me finish and then I'll show you how we should change this one, how you edit the program in case you don't have the right post processor for editing the program. Let's go to next. Next is now finishing. I want to close this message. I want to close this message inside this one. Now close that one, and then now open another one for finishing. Here I say OD finish turning, then remove this tool because it's for finishing. Select the tool for finishing, OD finish 35. You see this one, OD finish 35 left, and then this one is going anti-clockwise. Okay, So let's go to next. You'll see from here, stop it, the message from showing message into bracket, this one, like this, then enter again message to open for threading, then say OD threading. You need to understand this, how to edit the program in case you don't have the right post processor. Then pick the tool, remove this one, select the tool from your magazine, having this one OD as I did my naming, and then this one, you see it is already for Siemens using this cycle for the thread, which means it has put the thread that is using linear, but I can change here from linear to digressive. Then this is the diameter where it is. This diameter should be 48. Z is starting from 0. X is starting, the minimum is this one is okay. That is for I to know it is 48 minus pitch of 2, which should be 46 or 45. That's okay. Going to minus, let's say minus 35, okay, or maybe minus 33, okay. It is straight turning. There's no other things. Then this one linear starting from 3. Even this one I can put 3. This one I can say depth is 0.614 times the pitch, which is 2, and then 29. And this one digressive, number of roughings. This is 0, 0. Variable return distance, you can say 1. This one I can say 1. Okay, accept. I'll show you how to do this one. Yes, for the thread. Or you can as well now do this. For example, you say turning, then threading. From this threading, you can pick, say the pitch is 2, digressive. The diameter is 48. Z 0. It's going to minus 33, for example. 3, this one 30, should be 29. Let me put 29, blah blah blah. Then I change this one to second one, then I accept. Then I can remove this one, for example. I can remove this one so that it updates that. This is what we are doing for threading. Now let's go to next. This is now to stop the message from showing for the thread. And then we can go home. So I can now remove this one and say L711. Now go home like this. Go home. Yeah. Simple. Now remove this one to reduce duplicate, or I can say M4 equals to 5. Then I can say M09 or M30. You can stop everything. So this is how you edit the program. Now, there's something I want to show you when you are creating this. Okay, this 71 is not like all codes. We have done this one. Also, there's what you call workpiece. How do we set workpiece? So click here, enter, and then I can separate this information so that you don't need to show all this information. I can copy this. All of this one I can copy. Click cut, and then come here on this line. Click on edit, and then say build. Let's say info, and say this is my information, then accept, press the next key, enter, then paste the inside, then here change to this, then here come to various blank. This is what we have, this is what we are having. Yes, okay, that's our stock. Now this is what we have done from our CAM system, to this. So then also we need to set master spindle to 4. Set master spindle to 4, so that we are using master spindle of 4. Then come here, click on edit, say search where this S, let's say for example S, click OK, search. Then come here, you can either replace, for example this one, you can say S4 equals to, S4 equals to this, and M4 equals to For roughing, you are using left tool equals to 4. So it goes anti-clockwise. Then you got all the way to where this S. You can again search, then say, okay, next is this. So where this S, you put equals to this. And where's the M4, you put equals to 4, depending on the tool. For example, where the tool is, depending on the tool. You go all the way, again, say search, continue search, continue search. That one you can say S4 equals to, and then M4 equals to 4, except for the threading. Okay, even drilling, for drilling, I can put S3. So S3, S4 equals to this one, master speed, and then M3 equals to, sorry, not M3, but M4 equals to 3, because I'm setting my master spindle. Then continue search, search. You see, if you don't have the right processor, that's how you do it. M4 equals to, this is for roughing, equals to 4. Continue search. S4 equals to this, then M4 equals to 4, because this is for turning with the left tool. Search again. So S4 equals to this, and my M4 equals to 4. Check is the program for threading now. Continue search again. I want to say M4 equals to this, then M4 equals to this. Search again. Then is S4 equals to this, M4 equals to this, because I'm using left tool. Check here, these are the errors you can make. Search again, continue searching. Then is it for threading? Check. No, it's not for threading. S4 equals to this. Then here M4 equals to 4. Continue search. Now we are on the finishing. Search again. So S4 equals to this, and M4 equals to 4. Search. S4 equals to this, and M4 equals to 4, because I have set my master spindle. Search. S4 equals to this one, and M4 equals to 4. Search. So if you have the right post processor, you will not have this problem. And down this for threading. For threading, I can say S4 equals to this, and then M4 equals to 3, because I'm using the right tool. Yes, search, and we have finished. So this is the end of our editing. Then you can do a simulation to find the error before you now take the program to the machine. Find the error. The error may come from the G code. I see that it's telling you blocks N74 syntax error. How do you rectify this error? N74. You go to N74. Where's N74? N74. Where is it? This. N74, I think, should be down here. You see this one? N74. This is telling you syntax error. This is how you troubleshoot the program. In case of, because you may have edited the program wrongly, and then you carry on the error to the next phase. So remove it, then again come back, do a simulation again to check the errors, so that you troubleshoot. Troubleshooting meaning identifying the errors and then rectifying the errors before you take the program to actual machining. Let's see. Now, this is from our Autodesk Inventor. You see the message is displaying here. What it's doing? From there, I'm using what we call phase turning. You see what it's doing? Let me put on the side. Phase turning. Programming from Autodesk Inventor Ultimate CAM. Generate the G code. Now update to, or upload or load to your Sinutrain simulator, and then from there I proceed. And then also you see here, this one is too close to the chuck. So, or the jaws. How do you check this? So click here, edit, then come back to this one, workpiece. Click on the workpiece, then check this one, put minus 150, and then this one put minus 140, for example, minus 140 or minus 130. 140, 130, 135 is okay. It's okay. Then accept. From there again, do an simulation to check the error before you take the program to the machine. This is how programmers do. So you need to understand errors in your program. When you refine these errors, now you take the program to the actual machine, and this is what we do as 5-axis precision academy. You're able to fine-tune all the program from the design. You go to your CAM, fine-tune the program in the CAM, then take the code. Once you simulate it, now take the code. When it's okay, now take the G code to your machine. And this is what now CNC are doing with DMG Mori machines, advanced machines. Come to a center, you learn this. Yeah. Also, you see when it's approaching, like this grooving, why is it approaching from far? Is somebody who able to identify why is it coming from far? This error for grooving. So how do you identify this error and solve this error? I'm posing a question to you, the viewers. Why is it approaching from far away, from here? If you want to rectify the problem, why is it that I've already done my turning, but the tool is approaching far away before it goes to the material? And this is wasting time. This is wasting time. Remember, CNC is to do quality work, minimize time wastage. So why are we wasting time here? So if you want to know why this one is doing like this, come to our center. We will guide you, we will show you, we will train you, we will mentor you until you understand how to design, how to program, how to identify errors, troubleshoot the problem before you take the program to the actual machine. Because you may program, you give somebody who is a machine assistant or an operator to run the program on the machine. Then you realize maybe the part took a lot of time and you never knew what was happening. Yes? This is very important for you to understand these challenges. So you'll always simulate, identify errors before you now do actual machining. As you can see, what is now it's doing. It has finished. I can now go ahead and then I say part of. If I have a tool for parting off, I can go ahead, I add a part of. This is G code, normal G code. Let me add here part of. Let me MSG. This, then I say cut off. I'm adding this one, which this one is not from the CAM, but this is now from now software itself. MSG, close the bracket, close the bracket, sorry, close the bracket, and then here come to turning, cut off. I can put here the diameter, this diameter. What is the diameter of this? This one should be, is it 8? I need to check the diameter, the final diameter, because this one, this minus let's say more 20, for example. But you need to know how to do this, okay? 8, that is, I can put like 30. Then okay, but I need to put the tool. So what is the tool? From here, edit, select the tool. From selecting the tool, I want to do the OD cutoff. Where is this OD cutoff? Where is it? I think it's in the machine. This one on the machine. And then I can say this one having G96, S4 equals to, let's say 75, M4 equals to 4 because I'm using this, blah blah blah. All of them I can use F0.05. Already it's this one, for example, this one already I can put here 0.05. Safety distance and clearance, the direction is clockwise, blah blah blah, all of them. But you need to check the actual distance. So here, for example, here this is the original turning. Let me check original turning. I can show you the final diameter. This is for rough turning. Rough turning, we can move maybe to last stage, last code, last G01. We're able to identify the actual diameter. I will show you how to identify actual diameter. Actual diameter, and this is the actual diameter. This is the actual diameter. This should be X100. It should be X100. If you don't find it, for example, you need to go to your design. Let me go to my design. This is my design, and then I can come here to tools, measure, take this one. This diameter is 100. I can come back to my software. Then I go to where the part is, but for cutoff you need to use a blade, the blade one. So I can say this is now 100. Then from 100 I can say this 100 divided by 3, I get the 3. So I can put here as 3 like this. then I accept. So I'm able to do all these programs. Now let's go here and now again restart our simulation. And then there's a problem I told you that on the grooving. And that's why I said this one I'm leaving for the people who want to know. If you want to know this, you can come to a center. We'll show you how to do this. On the grooving part, the program on the grooving part, the tool is coming from far away. So how do we solve this grooving part? You see, it's coming from far away. G90, G95, G18, G97, blah blah. X130. Why is it coming from X130? And the diameter already we have turned. Like for example, this one, if we go to our program here, we can check groovings being done here. So let's do a measure here. From here, this is what we are doing. Diameter is 60. So you see, it is coming from far away. So how do we rectify this? It's coming from far away. So you see these values. So you will come to a center, will guide you on how to do this one. Yes, will guide you on how to do so that you minimize these errors. You see these errors, or even a grooving. I can change. I can measure here. Let me show you another tricky. I can come here. I measure maybe distance, assuming from the origin to the here. I am having maybe 50, and maybe this distance, if I choose also do a measure from here up to here, I'm having a distance of what? 7. So which means the B is 7, but I cannot do that one until you come to a center. Will guide you on how to do this one. So let me leave for the public those who want to learn and understand how to create a program. Come to a center. We'll show you how to program, how to design, program using any CAM software like Mastercam, SolidCam, Fusion 360, Esprit, GipsCam, or we train depending on what the client wants. We don't train because it is for our need. We train on what the client wants. And this is what you require as an expert in this field. You need to understand how to program. And this to understand various technologies. Either you're using a software, embedded software, or you're using a CAM way to create a program. This is what you always will require when you want to create a program. There are various factors you need to consider when you're programming, not just programming. And this is only for teaching purposes. But when you're doing actual machining, you need to understand the overhang distance. Overhang distance. You take the diameter of the final part, the maximum diameter of the final part, times 1.414 to know the distance of overhang, so that it doesn't wobble and the tool won't be affect the uniformity. Yes, the tool won't affect the uniformity. And this is what you require when you come to a center. This is what you require. I can even do override, for example. Override, you see. But this is not right because the tool is coming from far away. So what will happen? You see, it has finished. You see, we have our final part. We have our final part. So how do you come and understand? There are things like even pocket here, like milling, because this is a turning mill machine, milling, or all these operations. When you come to a center, we'll show you how to do this one from design to final stage of manufacturing. Welcome to 5-Axis Precision Academy. We are located in Karen along Rhino Park Road. We'll teach you how to design, program, simulate, check errors or troubleshoot errors, rectify errors, take the program machine. We're using a DMG model machines, turn mill and DMU 55-axis milling machine.